Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with analytic function problem. Look at this problem. If f of z is an analytic function with constant modulus, show that f of z is constant. Here z equal to x plus iy complex variable. The function of complex variable is nothing but f of z u plus iv. Now the given condition, if f of z is analytic function with constant modulus, therefore when I am taking modulus value constant, c is considered constant. Here f of z is nothing but u plus iv modulus equal to c. When I removing this modulus, u square v square square root equal to c. Squaring on both sides, u square plus v square equal to c square. Now to consider this equation number 1. For here suppose f of z u plus iv, the derivative differentiation of f of z, f dash of z, ux plus ivx, and taking modulus f dash of z modulus ux plus ivx modulus. To remove from this modulus, ux square vx square square root. This is the f dash of z modulus. Now squaring on both sides, f dash of z modulus square equal to ux square plus vx square. Now to consider equation 2. From the equation 1, differentiate 1 partially with respect to x. Differentiate partially with respect to x. When I differentiate u square, 2u into ux. Ux is partial derivative with respect to x. Plus v square differentiation 2v vx equal to 0. Now divide by 2. Therefore when I divide 2, ux vx equal to 0. Now to consider, this is the equation number 3. Then next differentiate 1 partially with respect to y. Therefore the differentiation equation 1 is u square plus v square equal to c square. When I differentiate partial with respect to y, 2u uy 2v vy equal to 0. Then divide by 2. Therefore u uy plus v vy equal to 0. Now the f of z, now this equation to consider 4. Now f of z is analytic function. F of z is analytic function. Therefore CR equation satisfied. So what is the CR equation? ux equal to vy and uy equal to minus vx. So this is the CR equation. Now consider equation number 5. Substitute 5 in equation number 4. So equation 4 is nothing but uy and plus vy equal to 0. Now u into uy is nothing but minus vx plus v into vy is ux equal to 0. Now minus uvx plus vux equal to 0. Now to consider, this is the equation number 6. Now equation 3 and 4, squaring and adding equation number 3 and 6. Therefore third equation ux plus vx. This is the third equation, squaring, adding minus u vx plus vux whole square equal to 0. Now a plus b whole square formula. A plus b whole square, a square b square plus 2ab. Therefore this term u square ux square plus v square vx square plus 2uv ux vx plus this term u square vx square v square ux square minus 2uv ux vx equal to 0. Now the common term here, this two term to cancel, therefore u square ux square v square vx square plus u square vx square plus v square ux square equal to 0. Now from this equation ux square, therefore I am taking common ux square, so u square plus v square into ux square plus then vx square common. Now u square plus v square into vx square equal to 0. From this equation these two terms are common. I am taking common out u square plus v square, then ux square plus vx square equal to 0. For this term ux square plus vx square equal to 0 because of since u square plus v square equal to c square is not 0. Therefore this term equal to 0. By using equation number 2, what is the equation 2? ux square vx square equal to f dash of z modulus of square. Therefore f dash of z modulus square equal to 0. Then remove the square, f dash of z modulus 0, f dash of z equal to 0, then integrating f of z equal to c. So what is a c? Constant. So now what is the problem? F dash of z, f of z modulus constant, show that f of z is also constant. Now f of z also constant. Thank you.